So today we're going to talk about inequalities. We're going to deal with polynomial inequalities and then some simple rational inequalities, which just means that the zero is already on one side of the inequality. And in our next lesson we'll deal with more complex rational inequalities. And the first thing we're going to do is we're going to solve this particular inequality by graphing. And so what we want to do is we want to take x to the fourth less than or equal to 4x squared, and we're going to bring the minus 4x squared over so that we have this. And then from there we're going to factor. And continue factoring. We have the difference of squares. So we're essentially going to graph y equals x squared, x plus 2, x minus 2. So if we think back to graphing polynomials, we know that the roots are x equals 0, x equals negative 2, and x equals 2. So I'm going to plot those. So we have 0, we have negative 2, and we have 2. And this is going to be, since it's x to the fourth and it's positive, we're going to be dealing with up, end behavior. Okay, so up. And we know that x equals 0 is a double root, so it's going to bounce off at that point. So we're looking at something like this. And so if we look back to the inequality that we wrote, we want to know when is this particular polynomial less than or equal to 0. There we go. So that area right there is where this polynomial is less than or equal to 0. So in writing our solution to this, we're going to do so in interval notation. And this is less than or equal to 0 from negative 2 to positive 2. And that would be the solution to that inequality. Now there's another way to consider this, and we could basically make a sign chart. And what we'll do is we'll divide the x-axis into intervals based on the roots. So we have a root at negative 2, we have a root at 0, and we have a root at 2. And we kind of want to know what the sign of the polynomial of this function is in between those roots. So if I put something less than negative 2, so if I say negative 3, I put that in the inequality. I see that I got negative 3 to the fourth power. That's going to be positive 81. So that's going to be positive 81 minus 4 times 9. So we know that that's going to be positive. If I put a negative 1 in there, I get 1 minus 4, so that's going to be negative. If I put a positive 1 in there, 1 minus 4, which is negative. And then something greater than 2, if I put a 3 in there, again, we have 81 minus 4 times 9, so that is also going to be positive. So we can see just from this sign chart that our function is less than 0 in this region. And since we want less than or equal to, we know that we're going to include negative 2 and 2. So that's one way where we can do it without graphing. And we're just going to practice on this next slide. We're going to take a look and we're just going to make sign charts based on these graphs. For number 1, we see that we have zeros at negative 3. We have another one at negative 2. And then we have another one at 1. And I just kind of put little dots above there so that I know that those are zeros. To the left of negative 3, we can see it's positive. between negative 3 and 2, we can see it's negative. Between negative 2 and 1, you can see that the graph is positive. And then to the right of 1, we can also see it's positive. So if I were to ask, when is this function greater than or equal to 0, your solution would be from negative infinity to negative 3 included, and then from negative 2 included to positive infinity. Now number 2 is a little different in that we also have some vertical asymptotes to deal with, and we need to include those because in our experience we know that there's different behavior changes at the asymptotes. So I'm actually going to put negative 2 down here since that's one of my vertical asymptotes, but instead of putting a little dot above it, I'm going to put a little x there to kind of indicate that that cannot be part of my solution because it is not part of this function. I have a 0 at 0. I have another vertical asymptote at 1, which means another x. I forgot my little dot there for the 0. And then I also have a 0 at 2. So we're going to put a little dot there. And I can see that the graph is positive to the left of negative 2. It's negative in that region. It's also negative in that region. It's negative again in that region. And then it is positive. And so if I asked, where is this graph less than 0, you would say, it would basically look like this. You would say, let me arrow down. I would say negative 2 to 1, and then 1 to 2. Okay, notice we can't include 1 because it is not part of this function. There is a vertical asymptote there. Okay, let's put this all together and let's solve this particular inequality. And we're going to use a sign chart. We're not going to graph this. So the first thing is I want to factor. So I have x squared minus 2x minus 3 less than or equal to 0. And then we continue factoring. And we see that we have zeros at x equals 0, x equals 3, and x equals negative 1. So those are the zeros. So draw, we have a 0 at negative 1. We have a 0 at 0. And we have a 0 at 3. So now we plug in values in these intervals and see if it is a positive or a negative. So if I put a negative 2 in here, negative 2 times negative 5 times negative 1. So that's negative, 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 gives us a negative. If I put in a 1/2, a negative 1/2, so negative 1/2, negative 3.5, positive half. So I got negative, negative, positive. That's a positive. If I put 1 in there, 1, negative 2, 2, that will be a negative. And then if I put a 4 in there, 4, 1, 5, those are all positive. So this will be positive. And since I wanted to know when this polynomial was less than or equal to 0, my solution set is going to be from negative infinity to negative 1, or from 0 to 3. And the reason I'm using the brackets there is because I have a less than or equal to 0. If it were just less than 0, then I would simply have parentheses instead of brackets. So that is the solution to that particular inequality. Pause the video and try these on your own, and then I will continue through and do the solutions, and then you can check and make sure that you're doing it correctly. So x to the 4th minus 14x to the 3rd minus plus 48x squared less than or equal to 0. And then if we factor, we end up with x squared minus 14x plus 48, and x minus 6, x minus 8. So our zeros are x equals 0, x equals 6, x equals 8. Make our sign chart. To the left of 0, let's put a -1. So 1, -7, -9. So that's a positive. And then if I put a 1 in, 1, -5, -7, that is also a positive. And then I put a 7 in there, 49, 1, -1, that is a negative. So less than or equal to 0, well, it happens at 0, so one way to illustrate that is like that, and then it also happens from 6 to 8. And you can also use curly braces for the 0, and then say 6, 8. So that would be the solution there. If we look at the next one, number 2, we're first going to do this, get everything to one side. I'm going to factor out a negative so that I can switch these. And then I'm going to take out x to the 1/3, which leaves me with x to the 2/3 minus 1. And x to the 2/3 minus 1 is actually the difference of squares. So it's negative x to the 1/3, x to the 1/3 plus 1, x to the 1/3 minus 1. So I can see that my zeros are 0, +1, and -1. So make the sign chart. -1, 0, and 1. And if I pick values, you will see that it ends up being positive here, negative here, positive here, and negative there. So I want to know when this thing is greater than 0. So that's going to be from -infinity up to -1, or from 0 to 1. When dealing with rational inequalities, we're going to make a sign chart as we have before, but we're going to put in the sign chart zeros and any vertical asymptotes, because we know that that's where the behavior can change and it could possibly change signs. So if we look, the 0 for this is when the numerator would be 0, and that happens when x equals 3. And then we have a vertical asymptote, -3. And then a vertical asymptote at x equals 4. So those will be the 2 points in my sign chart. So I have -3, and that's a 0, so I'm going to fill that in. And then I have +4. Remember, that's a vertical asymptote, so I can't include that in my solution, so I want to make sure that I put the x there. So let's try some values. So if I put a -4 into this thing, Negative 4 plus 3 is negative 1. Negative 4 minus 4 is negative 8. So I have negative 1 over negative 8, that's a positive. If I put, let's say, 0 in there, I get 3 over negative 4, that's a negative. And then if I put 5 in, I get 8 over 1, that's positive. So I want to know when this is greater than or equal to 0. So my positives, that will be from negative infinity up to and including 3. And then it's positive again, greater than 4. Remember that 4 is not a value, a possible x value, because it is not in a domain. So we will use a parenthesis there and go to infinity.